we were looking at channels. I'll just go over go-routines again, make sure everybody's following along here. How do we start a go-routine?
Go.
We use the keyword go, and then we invoke a function. So go, invoke a function. Call a function, invoke, same idea. So in our code, we are starting, how many go routines are in this program?
1, 2, 3.
3, that's right. It looks like there's 2, but remember, main is a go routine too. So there's 3. These 2, this one. Okay? And so go routines, they all can run simultaneously, but they don't necessarily have to run simultaneously. It just means we're making progress on all of them at the same time. So if we give it a period of time, say 10 minutes, progress will be made on all of those tasks. That doesn't necessarily mean they're happening exactly at the same moment. Okay. And then we can use a channel to communicate between 2 go routines. All right, so channels, they have a type, right? Chan space string. So this is the whole type, okay? There's a space between the parts of the type. And then the name is just a regular argument to a function. Okay, and so the type here is the thing that can be put on or pulled off of a channel. And we call putting something on a channel sending to the channel. And pulling something off is receiving from the channel. And we use this arrow operator to do that. So angle bracket, left angle bracket, dash. So you see the direction of the things, right? And so for sending, it's on this right side, and for receiving, it's on this left side. Okay. And we get the data, and we print it out, and then we wait. And we saw that what happened when we ran this was it prints it out, then it waits a second, and it prints it out. And what's happening with this guy is he's not just sending millions and millions of pings. He waits until somebody's ready to take it off, and then he prints it. Okay. So this is also waiting. Okay. But they happen in lockstep. So pieces of the code are happening simultaneously, and then they synchronize, and then pieces are happening simultaneously, and then they synchronize. Just like the Go, for example, we saw. Okay? So the question was, this is one side and another side. Well, we can have multiple things, multiple go routines sending to the same channel. We can also have multiple go routines receiving from the same channel. You can think of that like the line example, right? It's a line of people, right, or a queue, right? You know, and over here we have the registers or whatever in a bank, say, and there's people, right? And so the people have lined up or whatever. And we can think of this like this one line as being a channel. Okay? So this is a Chan person. And this is pulling them off. Okay? Okay, so this is like running next person, colon equal, arrow, channel, so it's called C. And then people coming in this way, right, it's like you're putting them on. So it's like C, you know, the next person. So a person might have Joe, whatever. So they're coming in and they're lining up. So the way this works, it's like a line, but the ordering here is not guaranteed. Okay, so it's not really a line. It's more like a complete mess, right? Where we have all these people just lined up, and it's going to be sort of random-ish who ends up being next. Okay, it's not a line. So everybody comes, and then the next person just randomly is going to be.
So when's has there been theories about how that happens, how it's chosen?
Yes, this is actually a careful part of the language to make sure that it's fairly done. Like it's random. That way the scheduler can do things that are appropriate.
See, this system, the system you just described, reminds me of those clubs you go to where, oh, you, and you, yeah, you two girls look great. You can come right to the front of the
That's
thing
right.
and go in. You know, you dudes, I don't know, move to the back.
It's as if everybody like comes up and they get thrown in this pen. They're all given a number. They put it in a bowl, you know. And the guy at the front, oh, there's a new teller available. He just pulls out a number and says, number 1,211, you're next, right? And that person goes. So there's no, well, you got here first, so you're next. That doesn't happen, okay? Everybody following? So, but this is like one channel, lots of things on this side, lots of things on that side.
So in your code, the example on 8, 9, 10, 8, 9, and 10, the lines on 8, 9, 10, where you're taking ping and putting it on the channel,
Yeah?
does it put all its pings on the channel at once, and then we're just waiting for, and then they're all in that pool?
No.
And in 18 it's blown off?
No. So, in this case, this is one task. This guy, right? And this is one task. One task can only put one thing on in the pen piece or whatever. And so it waits. It doesn't put a million pings on the channel.
So different tasks could put many,
Yeah.
you could put one thing on one channel. You could have 10 tasks and they each put one thing on one channel. You got 10 things on that channel. But each task can only put one thing on until that thing is off.
Right, they'll wait until they've been pulled off. Okay, so let's show an example that uses more than one coroutine. Really easy, let's just do another one. Okay. There, now we have 2 pingers and 1 printer. So now we have multiple things trying to ping and only 1 printer. What is this code going to do? Guesses? How have I changed the behavior of this program?
You're going to get randomness if you're putting two pings on one channel.
Yeah, so
You're starting to build that pool.
let me change this a little,
Slow it down.
and we'll give this our, ticket number, or whatever, int. And this way we can see who's putting the ping on, because otherwise we don't know where it came from. So now we'll know where it came from. It'll be 0 ping or 1 ping or whatever. So here we'll put 0 and 1. Okay. I got it vice versa. There we go. So now what do we expect this to do? What do we expect this to print out? We'll print out something here. What's this message? Where's this message come from? Pinger, right? And so what I would expect this program to do is it might print 0 ping, 1 ping, 0 ping, 1 ping. Or it might print 0 ping, 0 ping. Whichever one gets chosen is kind of random, right? But it will print from both of them. So it's just been pinging along the whole time. Let's try that now. Right? 0 ping, 1 ping, 0 ping, 1 ping. This is the random behavior. They may reach that point at different times. They may reach it at the same time. The point is what the channels go is going to try and randomize which one it pulls from. And the reason it does that is so that in general programs that are written the regular normal way, they don't end up with one process hogging all of this stuff. So one task doesn't end up, is the only one that ends up putting anything on the channel. Okay? And that's for a slow reader, a slow channel receiver. Okay? In other words, we're at a bank that only has 1 teller, and there's like one process, like suppose the process is the door, fielding people through it. Okay? And there's one door, the left door, and there's a right door. And the left door is the only one getting people, and the people on the right door are just waiting the whole time. Okay? Go is like, no, we're going to try and randomize that so that people on the left and the right are both getting it there. Okay? And that's what we're seeing here. 0 ping, 1 ping, 0 ping, 1 ping. But we can have multiple writers, that's the point, right? I can make another one really easily I can just make that, and now we should expect 3 of them. Right?
That's not really randomized, it's more just alternated, right?
Yeah, but the order I don't think is guaranteed, so, like maybe if I ran it again, it might be different. Let's see. Well, it's just always working out the same way. But I could make it a little more random by doing this. Just introduce some latency. Oh, it's still just doing the same thing. Oh, because I didn't do random, sorry. Oh, I forget. Is that right? Yeah, let's try that. Wow. Oh, there we go. Oh, no, never mind.
You just made the time random, right?
Yeah, the amount of time it takes here. Anyway, this isn't a very real example, so the point is it will fairly do them, and it's doing all of them. So we can have more printers. So the problem with this program is we didn't improve the performance. It prints at the same speed it was before, right? So why is that? Like when I first ran it, it printed ping, 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 1 every second. And now that I'm writing it, the pings are coming from different places. It's printing 0 ping, 1 ping, 2 ping. But it's still only printing them 1 every second, right? So this program is no faster than it was before. Why is that?
Bringing it to the bottleneck is the slowest thing.
Exactly.
Yeah.
Because there's only one printer. And he can only go 1 every second. And so he's the bottleneck of our program. These are all waiting on this guy to do stuff. And so we can improve this performance by adding another printer. So what should we expect this to do?
2 pings per second?
Yes, exactly. We'll see 2 pings per second. Notice that they're pretty much right at the same second. Why is that?
Is there already something?
It's because I started them immediately, and they both are sleeping 1 second, so they're pretty much on the same schedule, right? And so that's why we're seeing ping, 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 ping. Okay. So if we wanted to make one a little bit more delayed, how would we do that? How could we do that?
Change the time.
Right. So maybe we could introduce up here.
Would you have to make a completely different printer?
So now we're gonna, before we do the loop, we're gonna sleep for the delay. Okay, and now I'll pass in 0 for this guy, so he's not gonna wait at all. And then, let's say, 500 milliseconds.
So there's no timer on the pinging. Is there like, is the channel filling up with
Nope.
hundreds of pings?
No. The channel, remember, our channel is synchronized so that he waits. It's like a door, an entry door at the beginning of the line. He waits until somebody on the other end to receive it. So it doesn't fill up. There's no queue. It's like only one person can be
It's like a relay race. You got the one baton. He's going to stand there and wait until the other guy takes the baton.
Right.
So let's run this guy. That's better. So now it's about every half second, right?
It's no faster though. 2 per second, now it's 1 every half second. Still the same.
Yes, but now they're not.
Yeah.
Printing's more regular, right? So we could add 3, right, or 4. Let's do 4 because that's easier to multiply. And now we should expect 4. No, it was the text was corrupted. So now we're printing 4 every second. And so on, we could keep doing that. But we can also add more pingers and so on. You get the idea, you can start more of these that are all synchronized on this single channel, okay? So everything goes through that one channel and then back out again, okay? And,
Can you use channels if you don't use Go?
I mean, other languages have similar concepts.
I mean, the Go function in front of Go pinger, Go. If you just had a function that ran pinger,
So that's a good question.
could you still use channel?
Okay, so let's comment this out. So you want me to push something onto channel? No go routine here. I'm just going to push something to channel. What do you think this is going to do?
Well, you need someone to receive it in channel.
I would argue that this program will never get here.
Yeah, because it's an infinite loop.
You've got a baton, you're waiting to pass it on, there's no one there to receive it. You're just gonna stand there holding the baton.
So let's see if that reasoning is correct. Oh no, all Go routines are asleep deadlock. So Go was nice enough to tell us that we have screwed up. Right? It's telling us that this is no good. There's no way anybody will ever receive from this. So our program could never finish, so it told us it was a deadlock. Okay.
What about having more than one channel? And whatever is trying to push into a channel, pushes into the first available channel.
Aha! We will see that. 1 second though.
Yeah.
We will see that though. So the point is this, that will not fix our program either. So I'm trying to receive from the channel, and I'm not doing anything with the value, it's throwing it away, but I'm trying to receive from it. The reason this doesn't work is because this happens before this, because we're in a function. It always goes steps in order. This never finishes, so this can't happen, okay? So this needs to happen in a Go routine for this to work. So I can either make a function and put it in there, or actually you can just use, but that, often people see that and they're like, what are you doing?
It won't ever start your Go function because it can't finish the channel.
Yep, that's true too. So this ain't gonna work either. We'd have to move the order to there. So now this can finish because we started a Go routine, we started a new task, we created a new gopher, and he's ready to take the value out of the channel, and you take it immediately. Okay? Everybody following?
The bracket minus the, what does it do?
Yeah, so this is received from a channel. So
From a channel, so you have to create a channel and receive from it first?
so we created a channel here. This is receiving. Remember, this is an operator, so it returns a value. It's like when you do negative x to return the negation of x. This is like a unary operator, same idea. This returns a value. The value, we would store a message, and we would do something with it.
But you can receive it without putting it anywhere?
That's right. We can just throw away the value
Oh, okay.
if we want. You know, we just do
That's
that.
what you did there.
We're just
Just
Not
toss the
saving.
value away.
Yeah.
Instead of holding up a
which is basically the same as underscore equal, right? Toss it away.
I'm sorry, what's the purpose of a second blank parentheses?
Yeah, so this here, before the parentheses here, that's a function.
Oh, that's for the.
Create a new function.
Got it,
And then immediately call it.
okay.
Because a Go routine has to be a function. Okay? And so this could be the name of a function, like we were doing here. But we can also just create one and then immediately invoke it. Okay? Now JavaScript does things like this fairly often as well. But this is, you have to do it like this with Go because Go works with a function. Everybody following that? Okay. So now for the other case, what if I have multiple channels? Well, let's do a program first, and then we'll get to that one. Oh, copy that?
No. Yeah, but let's stop recording and bring back when you really
Well, the problem is create a program which prints hello world 5 times using 5 Go routines, okay? So let's do that.